All right. Hello, everyone. The stream can start. There we go. Okay. I hope all the channels are starting up. All the streams are going on. All right. Hello, everyone. That's been a... Oh, I have audio still on my main computer. How funny is that? All right, let's switch that off. We don't need an additional echo. Okay, so it's been quite a long time since last stream. I apologize for that. I wanted to do that more regularly, but I took on a consulting job to do some help for some people that I met, and yeah, I needed to take that job to make sure that the finances are all straight and working. Anyways, today we will do some assembly and just to get back into the swing of things, and I hope I can do some more streaming more regularly in the coming weeks. I probably should set up more like a day or time where I'm usually doing streaming. The problem is some people were asking me to stream more in the time that is convenient for European viewers. This is not currently very easy for me to do because it's either too late and I'm all groggy and tired and I want to go to bed, or it is too early and it always takes so much time to get going on a stream, like not only be ready with the project and the stuff that I will be showing, but also be ready with like brain and body, you know. Anyways, hi Micah, nice to see you here. It's great to have you there, and yeah, I'm following your streams. I see you started doing more regular streams. Yeah, thank you so much. Yeah, anyways, I did a few projects that are getting ready. So one of the things I wanted to do today is assemble this FTDI Multitool thing. As you might have seen in the previous streams, I was putting together those FTDI boards. And even though the Icebreaker has already an FTDI chip on board that I actually would like to get rid of, but getting the tiny FPGA bootloader running is still a little bit of a problem on the ICE40 Ultra Plus chips, especially using the Yosys toolchain, because the design for the tiny FPGA currently has a logical loop in it that is causing the timing analysis not to really work well, as far as I understand that. Anyways, to solve these kind of things, I will need some more help from other people. So Clifford and FPGA Dave, or Dave Shah, they offered to look at the hardware, so I have to send them the hardware. But to program this is a long ground cable for debugging, but to program the Icebreaker BitC that I made, you need an FTDI adapter. And so I went on and started designing an FTDI adapter that I would like using myself, because everything else is like so bodgy and so weird. So I want something that you have the FTDI chip on it, and then you can plug in different adapters to it. So make it a nice and modular system where you can have lots of different uses. Because I started just designing a programmer for the Icebreaker and then realized, well, this is actually, the FTDI chip can do so many different things, especially if you look into the MPSSE. So protocol serial engine of the FTDI chips. So it can do SPI, it can do I2C, it can do CPU type data bus, and few others, as well as UART for the USB to UART conversion. So having a nice set of plug-in adapters for different uses would be great. So again, like starting from just a simple programmer, I went down this path of, oh, we can add all these adapters. So I think I made the biggest order of different PCBs at OSHPark I've ever did so far. So we have the main board, we have a dual PMOD adapter. This is for the use with the MPSSC engine. So basically, sorry, it's the FIFO system. So you can connect 8 pins, or this is actually more. This is more like 1, 2. This is 4. This is 8. So it's 16 pins of data to control and clock and write and read and TXE and RXE, as well as data. And this is all you connect to have full speed or high speed, actually, FTDI connection to an FPGA, for example. So that's one adapter. Then I have just a simple 20-pin breakout, because I will get to it why I couldn't put a 0.1-inch header on this. There is a good reason for it. So 20-pin adapter, so you can easily make flywire connections. And now we have a bunch of 2 different PMOD adapters, single PMOD. So one is serial, one is SPI. And this is the reason why I had to use the smaller connector, because as you see here, this is the width necessary. This is the maximum width of a standard PMOD adapter. So I could not make the core board use the 20-pin connector, because that would be too wide to be used as a standard one PMOD wide adapter for FPGA board. So this was a necessary solution. Then we have a JTAG adapter, because you can use the FTDI chip for JTAG purposes. So there's a Cortex, ARM Cortex standard 10-pin connector adapter. That was easy. And then we have the one where it all started with, the connector for the Icebreaker BITC board. So there we go. So we have 1, 2, 3, 4, 5, 6 different adapters plus the main board. The adapters are pretty simple. There's not really any active parts on them, but we can develop more different adapters, for example, with optical isolation or your different project that you have. This is a very simple OSHPark board. It's a 2-layer, 0.8 millimeter thick PCB, and this is, and now I will explain why it is thin, because this way we can use, oh man, let me pull this out. We have a connector, just this nice connector, and this just fits on the edge of the board between the pins, and now we have a connector. It makes it very nice and easy to use. I'm not 100% sure this will stay like that, but that's for the prototypes, that's fine. The reason why I'm a little bit concerned, for myself, I would just leave it like that and just solder it by hand. The problem is, if we want to put it on 1-bit squared for people to have, is that I cannot pick and place these parts, obviously. I would have to manually solder them on, or leave them off and send them to the people for them to solder themselves. From my previous experiences with doing that and leaving the half pitch, so the 0.05-inch pitch or the 1.27 millimeter pitch connectors, is surprisingly, a lot of people, even though they have soldering irons, they have a lot of trouble soldering those connectors by hand. It seems to be an issue. I was very surprised to learn that. Not pre-soldering them on is for a lot of people a problem. And I don't know why that is the case, but we have to sort that out. So having just SMD connectors that are right angle that will go onto these boards is probably a better solution. The disadvantage, again, so it's like it's a back and forth always with the engineering stuff. So now, again, going back, if I pick and place those parts, they will not be always 100% square to the board. So having those adapters plug into this will be sometimes wonky. So I probably have to research and find some connectors that are this pitch, or have 20 pins, and have locating pegs on them. This makes the selection of those connectors, even though they are usually quite common, much less easy, because you need a specific connector with those locating pins. So that's something to be researched for the next revision of the board. All right, so where were we? I think what we have to do now is I already pulled together the bill of materials. Hey Vince, and hey GTS, nice to see you in the chat. So I put together, well, this is my magic box with parts, and I have so the only reflow part currently is this. So this is all we need to, it's the main board. Let me show that to you on here. So that's under the microscope. So it has a USB connector, a 12 megahertz clock. It has some flash for configuration of the FTDI chip, a bunch of passive capacitors mostly, a few resistors, the FTDI chip, and the 20-pin connector at the end. I put some of these mounting holes here. They might be useful if you want to make a case maybe, or you want to screw it into your project permanently. And on the back you have the other connections. So that's the multi-tool breakout board, or FT232 multi-tool. Okay, and I made, let's see, I made a placement plan as per usual. There's all the parts colored and marked. And I have a bill of materials. Let me move these parts here, because I put some parts on here. Okay, so there's the bill of materials, just exported from KiCad and marked, and check that I have everything here, and it should be all on the desk. Okay, so next step will be, let me put these in order. So here's my desk, here are all the different boards. Let's do that like this, there we go. So let me put this away. So if you have any questions regarding the FTDI board, let me know. I think this, so several people on Twitter said they like the modular idea, and I'm glad I'm not the only one that is excited to have it modular. So I was looking at already existing dev boards or breakout boards for the FTDI chip, and they all are pretty much the 2-row large like PCBs. They look like a so Adafruit has some, and some others, and making adapters for those is possible. I could just gone that way, but I thought let's do it Esden style and do it a little bit differently and make the whole thing. So I will cater to my not invented here syndrome. in this case, and we will see how that works out. Okay, so that. Now let's see. So the problem is now these boards are theoretically 0.8 millimeters thick, but actually when I measured them, they come from DigiKey, not DigiKey, from Oshpark. So these are nice Oshpark boards. This is just an option you choose when you upload a 2-layer board. And when I, will that be visible? Can we, yeah, wait. Can we do this? Yeah. So yeah, it's blinking, I need a new battery. Yeah, I know. But it's 0.95 millimeters thick. So it's not really 0.8, it's 0.8 substrate and probably an additional 0.05 millimeter, so 0.05 millimeter thick copper on both sides or something like that. Because these are 2-ounce copper boards. I don't need 2 ounces on this, but this is the only option if you order from Oshpark a 0.8 millimeter board. So they only give you the option of having a thicker copper on them. So I would prefer if it wasn't, because this allows higher fidelity of the PCB. But yeah, so the reason why I'm concerned about this is because when we do the stencil jig, if it was actually 0.8 millimeter thick, it would be exactly half the thickness of a 1.6 millimeter board, which these angles are made for. And because they are thicker than this, they are just slightly above the jig, which is a little bit annoying. I think it is manageable, but I would prefer if I didn't have to, if it was actually flush. So that's all. The alternative would be to shim it up with some paper or something, but I'm too lazy. I think this will be fine. Yeah, so I'm using 2 of the boards. I have 6 of them. We will probably assemble just 3 of them because I need 1 for me, 1 for Clifford, and 1 for Dave. And then if they work out, then we can order more boards and actually put them on panels and assemble them properly, if there's more people interested in them. So let me know in the chat if you are interested in this kind of an adapter board. That's always useful to know if people think that stuff is as useful as I think they are. Yeah. Okay. Oh, there we go. That should be a good stopper here. Stopper. Okay, so let's say it again. Why the FTDI chip? So first of all, this is the FTDI chip is the default programmer for the ICE40 FPGAs. So the FTDI chips are being used in many different applications, JTAG and USB to UART and stuff like that. But the IceProg program is using the MPSSE engine of the FTDI chip to program ICE40 chips. So I needed an FTDI breakout board. And then I looked around and I could have adapted something that is off the shelf, but then I realized, oh, we could have more adapters that have PMOD connectivity for FTDI boards. So we can have serial and SPI and test stuff and connect to the more FPGAs. So I was like, oh, I will design my own. So that's where it all started. Yeah, I could use other PCBs. Yes, I know, Bob. That's I am aware of this. I could have done that. That would be the alternative, but I don't know. Yeah, I end up doing this. I did that for a few other boards, and that worked out. But yes, I could actually use other PCBs too. So let me get some Kapton tape here. Yeah, I am aware of the FTDI gate too. I'm not oblivious to it. I am not a huge fan of FTDI as a company itself. Their tactics of trying to get rid of clones are very deplorable, in my opinion. This is not how you treat your customers, even though they have it's not their fault that they have broken devices. So if you are aware of the FTDI gate, I am aware of it. The problem is that for the USB to UART conversion, there is pretty much just two options. There is either the FTDI chip, well, yeah, there is more, but the common ones is FTDI chips and Cypress FX2 or FX3 chips. There is some other chips that can do only UART conversion. They are not as flexible as the FTDI. They don't have the MPSSE engine, and if you look at the prices, you could use a microcontroller and program it with some random software and develop that. But unfortunately, for this particular black box, it just does the job solution what FTDI does, and as flexible as they do, I am not aware of any alternative. And so basically, you either use it or you don't. We were even discussing on Twitter with some people that it would be pretty awesome if we could make an ASIC that has an RISC-V inside and all the other software or the other functionality very similar to an FX2 or FX3 chip, but with a RISC-V inside, and having all this kind of stuff. That would be really cool. But yeah, I wish some startup will pick up that idea and make a nice open silicon chip that will be a good competitor to these two options that are currently available on the market. Okay. Hi, Electron Ash. I'm reading the YouTube chats. Give me a second. The numbers are good. Trace impedance. Huh. Yeah. So yeah, that whole FTDI gate story was basically the fact that even genuine manufacturers, they just order parts and end up with fake chips, or at least considered from the driver standpoint of FTDI that they were fake, and they were bricking genuine devices. Like not even the supplier didn't even know that they were selling fake parts to their customers. It was that deep in the whole chain of things. It was really bad. Oh yeah. Hi, Electron Hash. Now you are in the Gitter chat too. All right. So we have this. I think it should be aligned well enough. Now let's pull out some solder paste and put that one together. I need something to put this on. There we go. Yeah, I have to be careful with my time because I only have like about a half an hour left. Today, the hackerspace today has also a meeting that I have to go to. So I might cut it off early, but at least we got a stream. Isn't that awesome? I wanted to stream yesterday, but then I started putting together all the necessary stuff, and it took me pretty much the whole day. And then I realized, oh, I'm not in the shape to actually do any streaming anymore. So so I didn't. So it had to wait. But this is a perfect way to celebrate a birthday. So with you guys on the stream. So that no worries. Okay, I think that should be more than plenty. Oh, thank you. Thank you very much. Yeah, just being reminded that one is 1 year older and 1 year less to do awesome stuff. Anyways, this is a very negative view of getting older. But yeah, let's not do that. Okay, so there we go. First board. There we go. Nice. Let's move this out of the way. Let's see if this aligns. Yeah, will that work? Yeah, I have to. This is the problem. I think one of the bigger concerns with getting boards from Oshpark is the fact that they are not separated. So you have to manually remove the tabs from the boards. And I think what happens is because of the tabs, you don't get exactly the same alignment in the stencil jig every time. So I have to reorganize the stencil pretty much every time between boards so that they are actually properly adjusted. There we go, 2. Whoa, the PCB attached itself, great. I have not seen that before. They are so light, they are so thin and so light that they stay attached to the stencil, Jesus. I'm covering things, I'm sorry. Okay, 1 more, just 3. Let's not overdo it today. Thank you guys, thank you so much. Stop counting? Yeah, I think I stopped. But what was it? Yeah, I think some automatic system sent out a birthday, like wishes. I think it was it? I think it was Nintendo or someone, and they put in your age in there, and you're like, yeah, I don't care anymore. It's like maybe when you're like 7 or 8 and less. Ah, crap. Okay, fine. Then you're excited about this number going up, but eventually you're like, yeah, I don't care anymore. Oh, my phone is ringing. This is not good. This is not what I want. All right. There we go. Yeah, I think that's good. This one didn't attach, so we will inspect those really quick, but let me clean up first. Where's my... No, there it is. Yeah, I did file down the mouse bytes. I actually used, because these boards are so thin, you can use an X-Acto knife to cut them off, which is an alternative solution. Don't use a new fresh blade, obviously, because it really ruins it pretty quickly. But if it's somewhat dull and you are already, or you dedicate an X-Acto knife blade for this task, yeah, I don't think this is a big deal. So yeah, I did cut them off. I still get this misalignment issue. And I'm just trying to figure out what the source of that could be. And my assumption is that it is related to the tab still not being cut off well enough by me and causing issues. So at the end, it's my own fault probably, but yeah. All right, so let's clean up. Let's get tissue. That's there we go. Clean, 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 clean. Yeah, if I leave it out and I don't clean it up immediately, this solder paste gets very dry and very sticky and really difficult to clean up. So I need to do that pretty much immediately. Otherwise. So how many gates? Gates is, so Electronash is asking how many gates the ice chip has. It's a 5K LUT, so it has 5,000, roughly 5,000 4-bit lookup tables. That's how the Ice40 fabric looks like. It's a bit different. You cannot directly compare it to Xilinx, for example, because I think their lookup tables are different bit count. So it is not apples to apples comparison there. Okay. So yeah, I can just remove it. Okay, I will assemble the rest at a different time. We don't need this here. We can reclaim the space. There we go. Bam, bam. Okay. So to say exactly this, the part used on the FPGA boards is the Ice40 Ultra Plus, so UP 5K with the SG48 package. This is a QFN 48-pin QFN package that it has. The advantage of the Ultra Plus scale part is it has some hard IP inside. It has several DSP blocks, and it has high current LED drivers. So 3 LED drivers, so you can have RGB LED connected to it. And it has I2C hard IP, and I2C hard IP, I think, and SPI hard IP. So there is some stuff that you can implement in hard IP and you don't need gates for, which is nice. Okay, so let's switch over. There we go. All right, so this one is a little bit, so let's see how terrible job I did here. It's not terrible. It should work, it should reflow. We might get some shorts. Yeah, it's fine. All right, let's go. Let's get cracking. So LUT stands for LUT, so look up table. That's basically what it is. So logic elements. Yeah, that is not. I don't think this is a misnomer. I think it's still. So Vince is asking about the toolchain. Yes, I'm using the Yosis, Arachne PNR, and Ice Storm toolchain. This like combines together the three parts. So you have the Verilog to net conversion, then you have Arachne PNR for the place and route, and then you have Ice that converts the placed elements into an actual bit stream for the FPGA. So that's how it works. Okay, we have a lot of 100 nanofarad, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. I should have made it available in the stream so you can see it, but so 10, that's correct. Okay, 10 100 nanofarads. Let's place them. I'm playing the pick and place machine once again. Well, until we can make a little bit more of those boards than just a few. Doesn't make sense otherwise. Yes, so that, yeah, Electronash is pointing out that 5000 LUTs is probably enough to emulate a bunch of things, like NES, C64, Speccy, cores. Yes, so there is also some soft CPUs or soft cores that you can run. There is the Lattice soft core that fits on there. There is also the RISC-V PicoSoc, that's how it's called. It's from the Pico RV32 that Clifford made. And the FPGA boards that I made are designed so that they can run code directly from the flash chip that is on there, on that board. So this will be very cool. I'm looking forward to seeing that. I should zoom in for myself because I don't see anything. Okay, these are holes. We don't need holes. We need to move here. Okay, so that's better. Now I see something. One. Yeah, let's pull those out. It'll be better. 1, 2. So they are next to each other. 1, 2. And then skip 1, then 2 again. Yeah. It's too much solder paste on this. This is not good. I'm not happy. I should have re-scraped it. Then we have this guy. And then we have one, skip 1, another one. Then we have 3 here. This one. Then this one. There, and one more. And we have one on this edge. Oh, come on. So these are all 402s, because I like this size. It's not very difficult. Oh, so last weekend or 2 weekends ago, something like that, someone approached me to help them assemble a PCB that is doing voltage regulation for the Novena open source laptop. that they have, and they wanted to upgrade to having a battery in there. So I assembled that, and the STM32 that is on that board is using 0201 100 nanofarad decoupling capacitors, and I was surprised how easy they were to handle in this kind of setup where you have stencil and you place them. They're not that as small as I expected and as painful as I expected. So I might actually up my game and go to 0201 parts. That would be fun. The only issue I have with that is, oh, you don't see anything, I'm sorry. I really need a crosshair on my microscope where it shows what is visible on the screen and what is not visible. Yeah, there was some focus issue. I'm sorry about that. I fixed that now. Yeah, the field of depth when I see it myself versus what the camera mounted on the microscope sees is different. So yeah, now it should be better. Okay. Yeah, that's the problem, that my pick-and-place machine can theoretically handle those smaller parts, but knowing how much parts the pick-and-place is throwing away when using 0402s already, I am a little bit concerned with that. So yeah, I probably will just stay with 0402s unless I have something very dense, or at least very dense for my type of stuff that I need to go to 0201s. So one example is the Great Watch that we will hopefully find some time to assemble sooner than later, because I have all the parts for the V2.0, I think, or 0.2 of the good watch. Have all the parts here. I just have to find the time to sit down and do some streaming, because I have the stencil, I have all the parts, I have the PCBs, because Travis sent me some PCBs, and I'm losing parts already. So yeah, that will be a fun project, but I have to find the time for it. What were the smallest parts? So Bob is asking. So Bob is asking that question knowing that the machine is quite old. So I think I might have mentioned that before. The design of that machine is from the early 80s. I don't even know how large the parts were back then. And the machine seems to be designed mostly for to deal with 0603 parts as the smallest parts, because the 0603 parts come on reels that are 8 mm wide and have a step between the pockets of 4 mm, I think. And all the 0402s come on reels that also are 8 mm wide, but the step between the parts is 2 mm. And to be able to use those on my machine, either the machine has to pick up twice per feed forward, so pick up a part a little bit in front of where it normally picks up, and then a little bit in the back, and then the feeder detects the pickup and moves the tape forward. So that is not very accurate, because the tape just bends and then parts jump around, so it is not very good. So some people started modifying feeders to change the encoder wheel to have more holes in it, so it is set up for 2 millimeters. But this is not a off-the-shelf feature of the feeders that Quad was making when they still were in existence, before they were bought by Tyco. I think Tyco started making those modifications. And you might know Tyco is already a company that is buying companies that are going bankrupt and are not very efficient anymore, and just squeezes out the last of the economic juices out of them before they get rid of them. So yeah, going to O201 is possible. There are special custom nozzles for it, because that's the problem with those. They come on the same type of tape as the 0402 parts. Yeah. Yeah, so Vince is saying that he should get O201 part to play around with. Yes, that's exactly what my experience was there. I was afraid of those parts, and then if you are able to deal with 0402 parts, there's no reason why you wouldn't be able to deal with O201s, especially with stencil and tweezers and a microscope. That's not a problem. Okay, let's see. Do we have all the parts? So 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4. 5. These look good, and this one looks good too. Okay, next part. Okay, let's put those back. So we're 100 nanofarads. Now, what is the second? Let's do the 10 picos. Do we have 10 picos? Yes, so these are for the crystal oscillator, 12 megahertz that the FTDI chip needs. I'm actually curious if anyone, so I'm sure there were people that decapped the FTDI chips. There are a thing that I was curious about the other day was how much of the functionality is implemented actually really in hardware on the FTDI chips, and how much of it is implemented in some kind of firmware. So does it use a microcontroller on the inside? Is that some weird architecture? Or yeah, I know some of this stuff has to be hardware, but yeah, that was. I know that some of the clones are basically just microcontrollers with compatible firmware that speaks the FTDI protocol. Pico, 10 pico, and 2 more 10 picos. There we go. Yeah, someone offered to assemble some boards for you on a pick-and-place machine. So maybe this is Peter's like pick-and-place machines. Can that become a thing? Yeah. Okay, so we need what other capacitors? There's a 10 nanofarad. 10 nanofarad, so we need 3 of them. 1, 2, 3. So if you are interested in the boards that I'm putting together, the design files are in the Icebreaker hardware repository. So if you go on GitHub into the Icebreaker-FPGA organization, because I made one, you will find a repository with all the design files in there if you are interested in looking at them. So it is nice and open hardware. There's already one person that made a compatible adapter for their FPGA project, so I have to provide them with one of the boards ASAP so that they can use it for their project. So if that is you who is listening now, because I don't remember the name I heard, send me a message, send me a PM so we can arrange that. 10 nanos. Okay, so that's done. Then we need, these are all the capacitors. Besides the 4.7 microfarad capacitors, these are 0603s. Let's put those on. And then we have a few resistors and few inductors. That should go fast enough. So how many? 1, 2, 3, 4. 4 per board. So 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, let's hope this is correct. Yeah. Yeah, we have a few dangling projects that I have to get to too. I need to get to the FX Grok FX2 boards for logic analysis. I have to get to that. I have to get to the bit magic, as I call it, so the higher performance USB 3.0 logic analyzer and stuff. I have to, yeah, we have a lot of projects in front of us. So yeah, I need to make it more of a habit to have these streams on a regular basis, because otherwise all this stuff will just not move forward fast enough, I think. Even though I'm actually doing a lot of stuff every day. But yeah, I want to share that with you all. So that is important. Anyways. Chook. There we go. Ugh. I had 2 coffees today, so I'm a little bit more jittery than usual. But that was necessary. Yeah. Yeah, so we are working on some retro gaming related stuff too. So you might be, so Electronash is mentioning that they are working on an adapter board for Game Gear Lynx, Game Gear / Lynx LCD replacement board, but with SRAM and voltage translation on it. So it could also run many of the 8-bit retro cores, which is really awesome. Or you are waiting for some boards from JLC at the moment that will do that. So this is really cool. we are working with Bob actually, and I think Micah is also a little bit involved, on a handheld game console, retro-inspired. It's called One-Up. It is based around the 1BitC STM32, and we are slowly progressing on that project. It's not very loudly advertised because too many cooks in the kitchen is a problem. So we are working on that. It is moving forward. Yeah, I wanted to show you guys the current status of that project after I'm done assembling this board, because Bob made really awesome new audio hardware for it, and I am working on new schematic for it that will also add an FPGA into the mix, which will make it very exciting. But yeah, it's more geared towards the Game Boy cases and stuff, so that's a little bit different than the Game Gear stuff, but it could probably run Game Gear emulators and cores. Yeah, all right, so where were we? Now we have all the capacitors. Now we need 10 kilo ohm is one resistor. That goes here. And then we have, on this side, we have the 12 kilo, let's see. Yeah, let's put the 12 kilo. This has to be the specific part because it has to be 1%. I think it is some current reference for the FTDI chip. I'm not exactly sure what they are doing with it. But yeah, so 12 kilo ohm, 1%. And we need just 4 of them, or 3 of them actually. 3, there we go. Wow, that's a massive board. Sheesh. That's awesome. That is very cool. That's a complex project there. Yeah, I'm glad this whole retro gaming and compatibility related stuff is really being done a lot these days. It's very... I had a Game Boy as a kid, and that was the only game console I ever had as a kid. So this is basically the core of my interests mostly, but I did recently get myself actually 2 C64s that I still am in the process of recovering. One of them I already plugged in and did some debugging on, and it turns out unfortunately the SID chip is burned through, so I need to replace the SID chip on that. I still have to check what the status on the other C64 is, because that's oh, this is even a 2-layer board. Jeez, wow, that's impressive. Yeah, I'm not bothering with 2-layer boards these days anymore. But for a really large board like this, that makes sense. The price difference can be significant. Okay. Okay, what next? Yeah, let's put the ferrites in, the 2 ferrites. 1, 2, 3, 4, 5, and 6. There we go. Okay, and oh yeah, Electron Ash is really doing a lot of retro-related stuff. That is awesome. Yeah, yeah. For large PCBs, OshPark is not is unfortunately expensive. Yeah, that's true. For small PCBs, they are great. They are fast. The quality is amazing, and that's what I use most of the time for my prototypes. But if you need like a large motherboard size thing, then yeah, you have to go to PCBWay or PCB Card or some Gold Phoenix or any other of the Chinese manufacturers. Unfortunately, yeah, I wish they could make the larger panels also as affordable as for the smaller stuff. Okay, then I need a 10 kilo, 3 10 kilos. It's just random parts here. 2, 3. This is just a pull-up, I think. I don't remember exactly. $10 kilo. 10 kilo. Oh, there it is. 10 kilo. And 10 kilo. Okay, what else? We need the 2.2 kilo ohm on top of there. 2.2 kilo. 2.2 kilo. There. You need 3 of them. This is for the flash. I don't know where that is come from. Oh yeah, so we are complaining about the cost of PCBs, and to be honest, the prices of PCBs went down so much over the years. Electron Ash is pointing out that their first 2-layer PCB order was $60 per board back in 5-6 years ago. Yeah, or no. Yeah, 10 years ago, roughly. Yeah, and $60, that's not bad. I remember trying to order some 4-layer boards from Eurocircuits, I think, like 7 years ago or something, and this was hundreds of euros. Like early 2000s. It was ridiculous. And the constraints were also incredible. You couldn't do any proper vias, any proper trace thicknesses. It was all had to be like super coarse and large to get at least like the most reasonable price on them. Thank God these days are not anymore true. We can order a lot more stuff these days that is much more reasonably priced. Okay, 1 mega ohm for the shield for USB. So 3 of them. 1, 2, and 3. There you go. What happened again. There we go. And 1 mega ohm. Then mega ohm. And 1 mega ohm. Wow, don't jitter. There we go. Come on, do it. It's the last 0402. Come on, you can do it. Okay, so that's done. Now we can put the quad resistor. This is just 410Ks for some pull-ups for the for the flash chip. There we go. 3 of those. 10K. Yes. Yep. Good. Yeah, I started using more and more of the quad resistors of different values on my designs, because it is very convenient, and for pick and place machine related reasons, it is every placement. It's like having 4 placements versus 1 is really a huge improvement in assembly speed. And each placement, I think, on my machine is not very fast, so compared to more modern machines. So it's a significant time improvement to decrease the amount of singular placements. And time is money, as you say. So yeah, I try to optimize that. Okay. Oh, if there's old project, what are where you guys are talking faster than I can keep up with, which is awesome. Yeah, that's good. I like good chats in the chats. Okay, what's the next part? Let's see. Let's put on the flash chip, maybe. Yeah. So what do we have here? This is the 2K2 ohm. Yeah, let's put the flash chips on. Okay. Ooh, I'm late. Damn. I have to leave very soon. So we will probably stop the stream and pick it up again after I'm back from the meeting. It's the local hackerspace has a board meeting that I have to attend to, unfortunately. Okay, so there's one. Okay, but I have to finish assembling this board before I leave, so there's no chance I will be late for that. Okay, 2 and 3. There we go. Okay, now that we have the flash installed, yeah, having a hackerspace is nice. at least it increases the probability of meeting like-minded people. It's difficult, especially with interests that are so technical as mine. It's sometimes difficult to meet people, but the big advantage I have is like I'm not far away from Portland, and it turns out they have a very thriving like tech interested community. So I try to go there on a regular basis to Dorkbot PDX. I've mentioned this on these streams several times already, I think. And this is full of really awesome people. I really enjoyed going there to hang out. And these are either former or current Intel employees, and maybe Tektronix that is also there. And a lot of artists that go there, because Dorkbot, the premise is a liaison between engineers that can do hardware and artists, so that they can help each other out with, so the engineers can help out the artists with their interesting projects. I did not even know that when I started going there. I only later learned that this is actually the premise, because all I saw was a ton of interesting people making awesome stuff. Yeah, I live in Oregon. Yeah, I do. Oregon is great. I really enjoy that place. Yeah, so there we go. FTDI chips. That's FTDI chips, and then we need the connectors on, and we're done. Okay, so let me... So I'm actually in Eugene, Oregon, which is 2 hours south of Portland. As the advantage is the renting prices are not as ridiculous as in Portland. But that's complaining on a high level, or it's whining on a high level. It's like jammern auf dem hohen Niveau, as you would say in German. Because this is still nothing compared to San Francisco, for example. So yeah. Yeah, whoever can afford living in the Bay Area, I respect that, because it's not cheap. I've been in the Bay Area before I moved here, but I'm glad I moved. It's nice here. I like having the weather. It's like you have rain, you have snow, and it is still less of a harsh weather than in Germany, for example. So there's more sunny days as far as I can tell. Yeah, I like this place. It's nice. Ah, come on. Did you get stuck down already? Ah, crap. Come on. Oh. This is painful. There we go. And it's there. Okay. There we go. Did that one. The FTDI chips are slightly too large for my tweezers, so this is a bit annoying. I could use the vacuum placer, but it's probably even more annoying than using tweezers. Yeah, I need a pair of vacuum placement system where it has vacuum and pressure, just like a real pick and place machine, where it can collapse the vacuum quickly. Because using the one that is on my AOUE that I have is it only has this like vacuum port. So you you cover it with your finger and then you release your finger, and it's not really collapsing the vacuum well enough. So yeah, I'm not a huge fan of it. I'm not using it that much. Okay, now connector. Yeah, I still have this feeling of like, oh, should I mention the city I live in? It's like, should I say it? It's like, but you can find it really easily. You just have to go on 1-bit squared and somewhere in the address is there pretty much. Yeah, and especially if you place an order from us, like the address is on the envelope. It's like it has to be. So yeah, but maybe I shouldn't, like, that reminds me of the fact that I was asking Clifford Wolf about oh, can you give me your email address so I can send you a message? Or no, it was the phone number. It was his phone number. I was like, hey, can I have your phone number so I can add you on Signal? He was like, just go on my website. I'm like, what? Yeah, I have my phone number on my website. I was like, why? How? What's going on? And he's like, yeah, I have it since like 10 years on there. No one really like uses it, or it's like I didn't see any issues with that. It's like sometimes I get a phone call from a person that uses my open source project. That was a funny mention. It's like he said that on Twitter the other day. It's like, yeah, I got a phone call from a person and they are saying on the phone, oh, I'm using your open source project and I'm having like issues with it. Can you help me with it? And he's like, what project? I have plenty of them. And it turns out it's one of the like smaller projects he made. It's hilarious, and it took a while to squeeze out of the person that was calling him which of the open source projects they are talking about to be able actually to help them. Anyways, people. Okay, so I think we have all the parts on these boards. Now I will go and put them in the reflow oven, and I will be back in a second. So I will mute this because last time it was making really nasty noises when I walked away from here. So I will. All right, so there we go. What happened? Why did the... Oh. That was weird. For some reason my Gitter chat just closed. I think I'm pressing a key combination that in Firefox closes a window for some reason. So yeah, I have to open it again. There we go. Okay, so yeah, anyways, it is in the oven. We just need a few more minutes and we should have that. Yeah, so the audio should be back on. So let me read a little bit. Yeah, not giving a specific address. Yeah, I already had an experience where I gave someone an address for them to drop off something, or I don't remember exactly what the reason was, but I mentioned my address, and then they came to my door and were asking really weird questions, very disturbed. It was unpleasant. So I rather. Yeah, try to somewhat control the amount of people that have my house address. But if you try hard enough, you probably will find it. So, yeah, I wouldn't want someone to go into my house and start taking stuff away. That would be unpleasant. Yeah. Oh, that's very nice. Yeah, nice chats about locations. Very cool. So hi Javier. Welcome to the chat. Yeah, so I should actually make a list of the hardware I have here. So this is an Amscope microscope. The exact model number I can't tell you out from the top of my head. It's a simulfocal version of the microscope. So it has the zoom knob, and it has the camera port. And it can do the camera and the eyes at the same time, can look through the lens. So otherwise, I have another microscope that I used before, but it has like a lever that you switch between the camera and one of the eyes. So you cannot look stereoscopically through the microscope at the same time when you are using the camera, which is very annoying and completely useless for the streams. So I had to get a different microscope, unfortunately. Yeah, the Amscope microscopes are actually very affordable if you look at their website. And these days, there's not really a reason to not get a microscope if you're doing any type of electronic assembly or like toy stuff. Even if it is your hobby, it's like you can get a full microscope setup for $300. It's, yeah, sure. If you are a college student and you really don't have money, then I understand. But getting a microscope these days is very affordable, thanks to the Amscope, for example. I can look up the exact model number. I think I used someone else's recommendation for the microscope, but yeah, I should look it up. I should put a list together because I'm sure there will be more people asking the same question in the future. So I should do that. Just like Micah has her awesome setup for what cameras, what the rigs, what hardware she's using on one of her GitHub repositories. That's very useful. I should do the same thing. Yeah. Yeah, the PO boxes only work. What is the question here? I'm not exactly sure. Yeah. So yeah, they are very affordable. So Electron Ash confirms that I was not that far off. $328. Yeah, out of stock. Yeah, look also on Amazon, because the Amscope scopes are also sold through Amazon. They might have stock there. Yeah, if you are planning to do any streaming, then I recommend going up in like getting the more expensive one that has the simulfocal capability, so you don't have to do one-eyed surgeries on boards. So, okay, I think the board should be almost ready, if not ready. I should have set a timer, I didn't. Okay, let me check on that. I'll be right back. All right, so there we go. Being on camera, yeah, it is. You have to jump a little bit over your own shadow. That's how I feel about this. All right, so here we go. Yeah, there we go. Woo! Let's zoom out and make it sharp again. Yeah, there we go. Assembled. Good job to me. La la la. Okay, anyways, let's see if we have any shorts. So the QFN seems good. Then we have the capacitors and the resistors. This all looks good on this board. Yeah, I have some shorts on this one. I have some shorts on here. So I will have to clean this up. Yeah, there are shorts here on the bottoms. Let's see, I have a short also on the USB connector. Yeah, I realized that there was too much solder paste on that on the board. The QFN looks good. Yeah, this guy also needs a little bit cleanup. And the USB connector looks good this time. And the last board. Sharp, sharp, sharp. Let's do it sharp. There we go. And yeah, these parts I need to fix this footprint. This footprint is not good enough for the gang resistors. I'm having regular issues with shorts between the pins of this. So I think I have to put less solder paste on them, on the pads, and do something with distances between the pads to improve the situation. It's always in the same spot, which is also interesting. yeah, so this is something for manufacturability that I would like to fix. Okay, so this is the connector. So we have, so now after I clean this up, I will also put on the connectors. So on this side, on this part, there will be this connector. So this is a 2-row 10 by 2 connector, and this goes on here, chunk, like this, like this, and we will solder it on. So yeah, but this has to wait for another stream because I have to run for that board meeting. So yeah, I closed the chat. I should be more careful. Okay, so everyone, thank you so much for joining the stream. I'm sorry it was a little bit shorter today, but I think we did good progress. We assembled this guy. On the next episode, quote unquote, in the next stream, I will assemble the connectors and we will do some testing on these boards. I'm not sure if it will be today, but I will try to definitely make a stream tomorrow. And thank you for watching. And so the big thanks to the people that are supporting these streams through my Patreon. If you look on the bottom, there should be a Patreon link, and there are specifically Kate Temkin, Kim Measles, Bob Miller, and Garrett Kelly that are donating $5 or more. So I wanted to send a shout out to them directly. Also, thank you, Micah, who is in here, who is also donating to me through Patreon. I really appreciate that. And yeah, thank you so much, everyone. There's also a LiberaPay page, which you might prefer using that if you want to support this channel. And thank you so much. I will be back hopefully tomorrow with some more assembly because this needs to be finished. Or maybe later tonight, who knows? Things can change. So thank you so much. Thank you for watching. And if you have been, thank you for watching.